part A, we need to draw a free body diagram. We're going to make up positive and to the right positive. The weight of the beam is 200 newtons, and that's going to go downwards at the 3 meter mark. The weight of the bear is 700 newton, and that's going to be at the 1 meter mark. The weight of the basket is 80 newtons, and that's at the end at the 6 meter mark. And there's going to be also tension from the rope at the 6 meter mark. And that's going to make a 60-degree angle with the beam. For part B, we try to find the tension of the rope and the horizontal and vertical components of the hinge. So for the first part of B, torque is going to equal 0 since it's in equilibrium. So the equation is going to start off with the rope being positive since it's pulling in the upward direction, with 6 meters times tension times sine 60 degrees. And then the basket is going to be negative since it's pulling it down with negative 6 meters times 80 newtons. And then the bear's weight is also pulling it down, so it's negative 1 meters times 700 newtons. And then the beam's weight, which is at the 3 meter mark, so it's negative 3 meters times 200 newtons equals 0. And if you calculate that, you should get tension equals 342.31 newtons. Now to the components of the beam. Since it's a reaction force, it's going to kind of act like a normal force. So it's actually going to be the force that the beam is exerting. So it's going to be, for the y component, which is also the vertical component, the equation is going to be like the vertical force plus 342.31 newtons times sine 60 degrees, which is also the tension, minus 80 newtons minus 700 newtons minus 200 newtons equals 0. And then you should get the vertical force is 683.55 newtons up. And then for the horizontal force, the only horizontal force acting on the beam is the tension from the rope, so it's the horizontal force minus 342.31 newtons times cosine 60 degrees equals 0. And then you should get that it's 171.15 newtons to the right. This is part C, where we're trying to find the maximum distance of a bear when the tension is 900 newtons. So the torque is going to equal to 0 since this is the distance right before the equilibrium breaks. So the rope's torque is going to be 6 meters times 900 newtons times sine 60 degrees. The basket is going to be negative 6 meters times 80 newtons. The bear is going to be negative x meters times 700 newtons. The beam's torque is going to be negative 3 meters times 200 newtons equals to 0. And then if you plug in everything, you should get that x equals 5.14 meters, meaning that the bear's distance from the hinge is 5.14 meters.